Hello, Assalamualaikum and good evening. Today, our group, which is Group 1, will present about Laminar and Turbulent flow. So, before we getting started, I would like to introduce our group member. So, firstly is Nufara Syahina Sadri binti Abdul Hakim, Nurain Izzati binti Izzah, Nur Hasanah binti Khalid, Nufara Natasha binti Khalid, and lastly Muhammad Adil bin Adnan. Before we move to the next section, I would like to introduce our group presentation agenda, which is firstly is introduction, objective, video conducting experiment, concept flow, laminar and turbulent, important to the food industry, advantages, application in daily life, conclusion, and lastly is appendix. So let's move on to our first presenter. For our introduction, Hasanah.
Hi, my name is Hasanah. Today I will give introduction of laminar flow and turbulent flow. First, laminar flow. Laminar flow is when a fluid moves in a smooth, straight layers without mixing. It occurs in liquid with low speed and high viscosity, like honey. The flow is orderly and predictable. Meanwhile, for turbulent flow, it is opposite from laminar flow. Turbulent flow is when fluid moves in a chaotic, swirling pattern with mixing between layers. It happens when the liquid is fast-moving or less viscous, like water. The flow is irregular and harder to predict.
Hi guys, Assalamualaikum. So today's experiment, I want to show you how honey and water flow. So as you can see here, I have honey, I have Tupperware, and I have some water. So to begin with, I will pour water into the Tupperware, and you can see how it will react. So I will raise the bottle at approximately 100 cm height into solid. So the observation is the water, when it touches the surface, is splashing around the area. So when it's splashing around the area, we call it as turbulent flow. What factors affecting turbulent flow? The factor is it has higher velocity. It has low viscosity and higher characteristic linear dimensions. So I will pour it back into my bottle. And now we see how honey flow. So I will raise it like water before. As you can see here, honey is not like water before. The water is splashing when it touches the surface, but the honey is not splashing because why? It's opposite like water. It has low velocity, high viscosity, and then the size of the pipe is quite narrow. But in my opinion, when it has a bigger pipe, it's like the same as how I pour honey into the Tupperware because of the velocity and viscosity. So that's so honey is laminar flow. So that's all from me. Thank you.
Hi, my name is Izzati and I'm going to share about the differences between laminar and turbulent flow. So, laminar is characterized by its smooth and orderly nature, where fluid particles move in parallel layers without mixing. This type of flow occurs at low Reynolds number, typically less than 2000, indicating a smooth flow. The velocity profile in laminar flow is parabolic, with the highest velocity at the center and decreasing smoothly toward the edges. This results in a predictable and constant pressure distribution along the flow path, making it easier to calculate and manage. For turbulent flow, in contrast, turbulent flow is chaotic and irregular, with fluid particles moving in random direction and mixing extensively. Turbulent flow occurs at high Reynolds numbers, typically greater than 4000, indicating a chaotic flow. The velocity in turbulent flow is less predictable with the presence of eddies and swirls. This leads to a significant and unpredictable variation in pressure, making it more challenging to manage. The intensive mixing in turbulent flow enhance the transfer of momentum, heat, and mass. Understanding these differences is crucial for application in fluid dynamics, where control of flow characteristic is essential.
Hi, my name is Falisha. So there is three importance of laminar and turbulence in food industry. Firstly, we have sterile environments. So laminar flow is crucial for maintaining sterile condition in food packaging and processing. It prevents contamination by ensuring that air flow in a controlled manner. Next is precision mixing, a process requiring precise ingredient proportions like emulsion or sauce. Laminar flow helps achieve consistent results. It minimizes unwanted turbulence that could affect product quality. Lastly is heat transfer. In process like pasteurization or cooking, turbulent flow promotes better than heat transfer rates. This efficiency is crucial for ensuring food by effectively killing pathogens during heating. In summary, both laminar and turbulent flow playing vital roles in the food industry. Laminar flow is essential for maintaining sterility and precision, while turbulent flow is the heat transfer efficiency. That's all from me.
Which are laminar flow and turbulent flow? First, laminar flow can reduce the risk of spreading harmful substance, making the working environment safer. It's about laminar flow is when air or liquid move in smooth, even layers. This type of flow is important for keeping workplace safe, especially in lab and hospital. It helps contain harmful substances like germs and chemicals, preventing them from spreading into the air. For example, laminar flow hoods filter the air to trap dangerous particles, improving air quality and protecting workers. By reducing cross-contamination and keeping harmful substances contained, laminar flows make it safer for people to work in sensitive environment. Overall, using laminar flow is essential for maintaining a clean and safe workspace.
What is the application of laminar and turbulent flow in daily life? First, for laminar flow, we can see that in daily life, in water pipes, in small pipes with slow water flow, water moves smoothly in layers, providing efficient flow without much energy loss. Next, we have a blood circulation. Blood flow in smaller arteries and veins in mostly laminar, allowing smooth delivery of oxygen and nutrients. Last but not least, we have ventilation system. In clean rooms or operating theaters, air moves in laminar flow to prevent dust or contaminants from spreading, keeping the environment sterile. Next, for turbulent, we can see in application in daily life. First, by high-speed motorboats. As a motorboat moves quickly, the water behind it becomes turbulent, forming waves and white caps that indicate chaotic water flow. Next, when we do shower spray, if you turn on the shower to full blast, the water sprays turbulently, mixing with air and creating an uneven flow for more vigorous wash. Last but not least, we have boiling water. When we boil water, the rapid movement of hot water and bubbles create a turbulent flows, which helps heat the water.
In conclusion, in laminar flow, fluid particles move smoothly and orderly in parallel layers with little mixing, typically occurring at low Reynolds numbers less than 2000. This makes laminar flow is predictable and steady with a parabolic velocity and consistent pressure distribution. Conversely, turbulent flow is chaotic and irregular, with fluid particles moving in random direction and mixing extensively, usually at high Reynolds numbers greater than 4000. This result is unpredictable and unsteady flow with fluctuating velocity and pressure due to the presence of eddies and swirls. Understanding these differences is crucial for application requiring precise control of flow fluid. Thank you.